Thank you. Nice to see you all. So I'm now managing the analytics department of Agder Energi Nett. Previously, I've been working on smart grid, on smart metering rollout for the past 9 to 10 years. And the story I'm going to tell about here is how this went and how it changed our organization. So Agder Energi is located in the south of Norway. We are a mid-sized Norwegian company with about 200,000 customers, making us the fourth biggest in Norway. So the story I'm going to tell you here is about the change we went through from 2010 and until today. And the background for this is the rollout of smart meters. So we went from an analog situation to today collecting a huge amount of data. And the key content here is the choices we made, the lessons we learned, and the benefits we gained, and what were the success criteria. So this is the content. First, a little bit about Agder Energi, and then about our strategy for this transformation. Then moving over to the importance of taking control of data handling, and finally ending with how we engage the employees to take part in this change. So Agder Energi is covering all parts of the electrical value chain from production through energy management. We own and operate the grid, and we also have a retail business selling to customers. So we are in all parts of this value chain. We have a lot of engineers, of course, but we are now moving towards being more and more competence-based. So it's very important for us to make our employees to be innovative and developing new ideas. So over the past few years, we've had a lot of focus on innovation and digital transformation, putting us on the list of the 25 most innovative companies in Norway. So our vision is to be one of the leading companies in the renewable sector in Norway. And those of you who know Norway, you know that it has a lot of mountains and it rains a lot, so it's perfect for hydroelectric production. The grid company is in charge of the lines and cables and operating that in the best possible manner. Here are some key figures, and one thing that has been a huge focus for us is to prepare for the future. Because as was mentioned here in the introduction, we see a lot of change in the customers' behavior. They are getting new electrical devices, new cars, and the power consumption is going up quite much. And there is a general trend towards more and more electrification. So that's very short about Agder Energi. When you get the slide pack, there is more, you can read about it, but let's get to the most important things. So the strategy. Back in 2010, we were facing the regulations saying that we had to roll out smart meters to all the customers. And we quickly saw this was a good idea, but to take full benefit, we wanted to fully digitize the entire grid. So the regulation says it's only related to the customer level. So in order to get instruments and data input from the other levels of the grid, we had to ask our board for additional investments. So we're going to the boards and saying we need this much money to do the mandatory smart meter rollout, and then we need even more to do the implementation of the rest of the grid. And the board says, yeah, sounds good, but hey, what's in it for us? What's the benefits? So the first thing we had to do was to start with a good business case, showing that this was really a good idea. Now, the business case for a grid company is basically to build and operate a grid in an efficient manner. And we could argue that by collecting data, we could focus on a lot of areas that would give us significant benefits. And these areas are, as shown here, voltage quality. By monitoring and correcting in the grid, we could easily provide the correct level of quality to the end users. Energy and power balance. There will always be bottlenecks in the grid. There will always be some loss. If we would be able to observe these bottlenecks and loss, we could more easily make investments where necessary and avoid investments where it wasn't necessary. Ground faults and interruptions is related to security, safety for end users, quickly fixing errors when they occur. And that's also very much depending on good input of data and quick reactions. Substation surveillance is necessary to do a very good and efficient maintenance. So by observing, we can take action when it's needed rather than on a regular basis. And finally, demand response is about understanding our customers, motivating them to balancing out the loads so that not everyone is using very much energy at very short time, but if we even it out, we can build the grid in a more efficient way. So those are the business cases, and they were quite good. So the board said, yes, you can have the money. So then we went ahead and worked on the instrumentation. So from about 2015 to now, we have been installing meters around in the grid. And this has been done on all levels. So at the customer levels, about 200,000 installations. At the substation level, about 8,300 installations. And at the core grid, the regional grid, about 460. And this is now giving us a lot of information to work on. So to move to the benefits, so now we are getting the data. We can start working on it. And our approach is to take the domain experts, so the engineers, the people who know the grid, who know the problems, and put them together with the data scientists and make them work in close cooperation. So the domain experts know how to formulate the problems, they know what gives value, and the data scientists know how to put data together, structure it, gather it, present it. Here's an example. In this picture, we see in the map, there is a substation. That's the orange dot, and all the connected customers are the blue dots. On the graph, we can see the energy flow through the substation. That's the orange line, and measure at the customers. The sum of all the customers is the blue line. And the difference between the lines is the loss. And the small bars up here, they are the loss in percent measured on the left axis. And in this case, the loss is between 10 and 50%, which is much higher than it should be. So there must be a problem here somewhere. So now the engineers can go out and take a look. Is the grid here, is it old? Does it have very thin lines? Does it have very long lines? Maybe there is some technical error, maybe a bad insulator, maybe there's even theft, maybe there is some consumption that we don't know about, but that we should charge. We have these for about 8,000 substations, and we now can apply rules and machine learning to go through it and give us indication of where we should start working on which are the most severe problems. Another example, substation load. The blue line is the load of the substation, and the purple and red, the orange and red vertical lines are the thresholds for 100% and 120% load. So the substation can easily be in 120% load for a short time when it's cold, so when it's winter, but not for a longer time. So this situation will severely either reduce the lifetime of the substation, or it will cause a blackout. So we should really replace this one, upgrade it to a higher level. So we have already seen a lot of cases where we didn't know there was a problem, but now we can see it. And we've also seen a lot of cases where we had planned upgrade, but then we look into the data and we see it's not really necessary because there's not as much load as we thought it would be. So we already have significant savings on this case. So this strategy of ours to fully digitize the grid is definitely a success. We're very happy about it. And we are actually the only grid company in Norway that did this to a full extent. The others did it partially or not at all, but we're quite happy that we took the step and took the investment. And I guess the others are coming after, but it takes time. And the key thing is to convince the management. So next topic, take control over data handling. So in 2015, we started installing the first meters. And it was quite obvious that we would get a lot of data, and we were wondering how should we work with them. At the same time, over the years, we had developed IT platform with a lot of systems with different purposes. There are some systems for customer data, there are systems for grid data, there are systems for operations, there are systems for balance settling. So our leaders were saying, okay, hold on, no more system, please, let's use the ones we have. Let's use the systems we have and try to work with the data in those systems. So that's what we started with, and we quite easily run into problems. First of all these systems have a vendor, and we automatically got into a situation where we customers give a requirement to the vendor works on it, gives a product back after 3 months, and we say, this is not really what we wanted, let's do it over again. So there was a very long time to market, very slow changes. It's also that with all this new data, we have new situations. There are completely new things we need to do research on. We need to sit down, look at it, work with it. We can't really give it away to some external part and then wait for a result back. So, and we also needed a much more agile working. And basically, the legacy systems were not made for big data. They didn't scale at all. So this strategy failed terribly. We just had to scrap it and start all over again. And the next year, we realized we need to establish a new platform for handling the data. And obviously, as you can see, it's cloud-based. It's Microsoft Azure, which is the choice of our company as a big data platform. And we immediately gained quite a few benefits. We also choose to get resources to come and sit with us and work on establishing data structures, gathering data, making the visualizations, and working very close with our engineers. This made it possible to build competence internally, and it also ensured that we have control over our data and we can work on it in a very flexible manner. And it's also a future and scalable, future-proof and scalable solution. So we're quite happy with this choice. I guess today, when it's 2019 and everyone's talking about cloud, you can say this was a pretty obvious choice, but we had to go through it, and we made a choice in the right time. So the success criteria in all these different choices we made is to make a very close link between the domain experts and the data scientists. That's the core point here. So with our grid here, we now collect data. So we have a lot of data input. We have chosen tools to work with. We're not only using Azure, we are also using ArcGIS, which is a product from Esri on map applications. But the most important thing is the competence, to build competence in the organizations and to make domain experts and data scientists work together. So, last point here, to engage the employees. It's quite well known that people usually don't like changes. They want to do the same as they did yesterday, and they are skeptical, and especially if it's great distance to the background for the changes and the reason. So this can be quite hard. So we understood that we had to get them into it. And the one thing we did, and I think I've heard that in several presentations here, is to start with a minimum viable product. So just take a small set of data, structure it, visualize it, and show it to the end user, and they will immediately be engaged and happy and interested and ask for more. And then the snowball starts rolling. So this worked pretty well, so involving people, making them sit with us and tell them what do they want, and how can we best show it, make mock-ups, draw on sketchboards. So that's a very important thing. To take this to a bigger context, the digital transformation is easy when it comes to technology, but it's hard when it comes to organization and culture. So we started a research program funded by the Research Council, where we are looking for the capabilities for a competence-based organization. So what are the capabilities this organization needs? And our focus is on innovation, influence, analytics, and cooperation. And this has been proved quite well so far, and we have had a lot of cases that we didn't think of when we started it, and they're just coming up. People are getting new ideas. So here's an example. This is Rolf. Rolf is in charge of the overview of all the small-scale production in our grid. So solar panels, small-scale hydroelectrical production. And in the summer, when the sun is shining, the newspapers are calling to Rolf and they're asking how much input do we have today from the solar panels? How many do we have? What's the increase since last year? So Rolf is asking a lot of questions, and he is using a lot of time to find these answers from his spreadsheets and digging into systems. So he said, give me something, give me a tool here. So with the platform that we established and with the data we already collected, we could easily assemble that and give Rolf something he could look onto when he had these questions from the newspapers. So he was easily happy with the solution. Now, in this case, the value itself is saving some hours for Rolf, but this is a very low-hanging fruit, and it's a very good incentive, a good feedback to the end users and to the employees to show them that there's actually something very easily reachable here and very valuable for you as a person. So he's now very keen on new ideas, evolving it, just showing the possibilities, and he will get new ideas. So what you have seen so far is mainly visualization, describing the situation as it is. Obvious way further is to do predictive and prescriptive analytics. Some obvious cases are to predict outages. Norway is a country where it's snowing and blowing a lot, so we have outages quite frequently. There are trees falling off the lines. We have a lot of overhead lines, and there are people in our grid being without power for 1 day, 2 days, 5 days. So we need to be ready when this hits us. We cannot stop the snow, but we can be ready. Another case is load forecasting, to see how will it evolve over the next days. And of course, risk-based maintenance, to go to the spots where maintenance is needed on a risk-based approach and not a time-based approach. So the summary, key takeaways here: secure management support for the digital strategy, assure data ownership, you own the data, that's the goal of the future, and engage employees to make them embrace the changes, to make them work with the changes, and they will be happy following this evolution. Okay, thank you.
Thanks a lot, Per-Oddvar.